My name is René Groben. I'm a project manager at the microbiology group at Matís, and I will give you a short presentation about the research on increasing bioavailability of sustainable aquafeeds and food safety. With the growing global population and the need for healthy, nutritious food, seafood is in demand as never before. However, current fishing practices put a lot of pressure on marine ecosystems, and fish stocks worldwide are often in danger of overfishing, and this makes this practice unsustainable in the long run. Aquaculture, which is the rearing of aquatic organisms in large tanks on land or in open pens in the ocean or in lakes, has the potential to solve this problem and produce high quality food in large amounts. As a result, aquaculture quickly became the fastest growing industry in the food sector. There are, though, problems associated with growing aquatic organisms in aquaculture, and one of them is the need for sustainable sourced food and feed. At the moment, the necessary protein sources and largest component of aquaculture feed is fish meal, meaning that low-value fish is caught in the ocean or reared and to feed the more valuable fish in the aquaculture. This system does, of course, not solve the problem of overfishing and depletion of fish stocks, and in the long run, this is also not sustainable. So we need to find alternatives. In Master, we did trials with different kinds of alternative protein sources in aquaculture feed for Arctic char and Atlantic salmon. We used proteins from waste streams of the dairy and beverage industry, and as well as insect meal, and replaced a certain percentage of the fish meal in the feed with it. In addition, we supplemented the feed with selected prebiotics and potentially probiotic bacterial strains to test if they increase the bioavailability of these feed. We think that these might change the composition of the microorganisms in the fish gut and have beneficial effects. We measured the impact of these treatments by analyzing the growth rates of the fish, the quality and sensory values of the fish fillet, the gut microbiomes, and the product safety through microbial and chemical analysis. The results showed that fish meal could be replaced by up to 15% with alternative protein sources under prebiotic supplementation without any negative effects. There was even an indication that some of the probiotic bacterial strains had growth-enhancing properties both for Atlantic salmon and Arctic char when they were administered with the feed. Furthermore, the study showed that these probiotics inhibited the growth of pathogenic listeria on fish fillets without having any adverse effects on the quality of the fillet. So this makes them a valuable tool to improve food safety in the aquaculture. We think that these beneficial effects could have been achieved through modulation, meaning changes of the microbiome, the microbial composition in the fish gut. To summarize, our research has been shown to the possibility to use alternative and sustainably produced protein sources in aquaculture in combination with pre and probiotics. Not only have they no negative effects, but we could even show that they might increase growth and reduce infections with the pathogenic listeria, making them a promising way forward towards safe and sustainable aquaculture production. This work was done within the Master project by researchers from Matís and Ifremer, and we would like to thank all the colleagues for their successful combination.